Alright. This video is going to be about teaching protein synthesis, not protein synthesis, but protein digestion in the stomach. Alright, the thing you gotta know is that there are two types of protein. Number one is dietary. And then the second one, let me run this, endogenous protein. Endogenous. Endogenous meaning existing, therefore genus is protein, so existing proteins that are already in the stomach. Now proteins are made out of molecules called amino acids. These amino acids are held together by strands of peptide bonds. And proteins are many bonds sticking together. Right? For example, the steak that you eat has a lot of these amino acids held by peptide bonds, and that is the essence of what a protein is. And the reason why we have to digest it is because in its raw form, these are too big to go through they're just too large to go through the openings of the blood vessels, which can be absorbed so that your body can gain the nutrients. So we have to break it down. So the first step is to consume it. So that goes into your oral cavity, where you have several enzymes that break it down, and you chew it down and it goes down the esophagus. Now this whole process of protein digestion starts when two enzymes, pepsin and pancreatic proteins. These are two enzymes that exist in different parts of your body. One, pepsin exists in your stomach. Two, pancreatic proteins, as you can guess, exist in your pancreas. Now, your pancreas makes it, but it actually transports it into the duodenum, which is the first part of the small intestines. So what these enzymes do is actually break down these peptide bonds, right, to smaller, if not single bonds. Stronger bonds will bypass these enzymes and remain a bonded amino acid. The second phase of enzymes is called aminopeptidase. Aminopeptidase. These enzymes will break down molecules that bypass the first set of enzymes, right? The pepsin or the pancreatic proteins. And some will break apart into single amino acid molecules, but there will be just sturdier, tougher ones that bypass the second phase of enzymes. And then this is where we enter in tertiary and secondary active transport. Now we mentioned that there are amino acids that have been broken down to single molecules, right? Those will enter the membrane through secondary active transport. This starts when the membrane initiates an active transport system. This starts by ATP being absorbed, right? And you have two molecules coming in and coming out, or one molecule coming in and coming out. You have sodium getting out of the membrane and potassium going in the membrane. This sodium will create a concentration gradient that is lower inside the membrane and that is higher outside. So the existing sodium ions will create a sodium concentration gradient. It will bring sodium in and bring the actual single molecules inside the membrane. Now we mentioned that there are peptide bonds or small peptides that bypass two phases of enzyme breaking apart. So in order for these to enter the cell, the same active transport will occur. This happens when the ATP being absorbed, potassium going in, and sodium going out, creates a sodium concentration gradient. the sodium concentration will bring in sodium as well as the peptide bonds. No, before that, I'm sorry. Cross that out. It will bring in the sodium ions and bring out hydrogen ions. At the same time, the hydrogen ions will bring in the small peptide bonds, finally entering the membrane of the lumen. There's the last final enzyme phase in the membrane called intracellular peptidase. This will break down the last bits of amino acid bonds into their respective single molecules. Finally, these single amino acids will go down through channels to enter in the capillaries of the blood. And that is, it's summed up.